Good morning. We're going to take up where we left off on synthetic division. Here's the example we're going to be using in this case. X cubed minus 13x squared plus 46x minus 49. We're going to divide it by the factor x minus 8. Now, when you do synthetic division, instead of using the factor like we did in long division, now we're going to use the solution. Or in other words, if x minus 8 equals 0, take the 0, the 8 over. So we have a solution or a 0 or a root of x equals 8. So that's what we're going to use for our divisor in this particular instance. First step, write our 8 in the box, like so. Then we remove the variables and just put the coefficients for the terms of the equation that we're dividing. Now, as we divide by this, since we are actually dividing by x minus 8, in our final answer, all of the terms will be reduced 1 degree because we will have divided x to the first out of each of these powers in turn. Okay, now for the process of synthetic division, you draw a horizontal line below, an addition line, if you please. Okay. First step is we just bring down the first term. Now we're going to take our divisor times that first term to get our value here. Then our next step is we are going to add these two down. So negative 13 and positive 8 give you negative 5. Next step, take the divisor times this negative 5, which gives us negative 40. We add down, and we're ready to multiply again, in which case we get 48 with a remainder of 1. Now, there are two differences in long division and synthetic division, two major differences. One of them is instead of using the factor x minus 8, we use the 0 or the root of x equals 8. The other is instead of subtracting down, we add down. So those are opposites, a pair of opposites which offset each other. Now, here we're continuing on this problem. We've got this worked out. We need to put the variable back into the equation, and we need to go ahead then and deal with that remainder. You can see what it says here about that. The rightmost one is considered the right remainder. So this is now, instead of an x cubed term, is now an x squared term and an x term. And that constant, of course, would become our y-intercept were there not this remainder. So that generates the answer here of 1x squared minus 5x plus 6 plus in fractional form, we have the minus 1 over the factor x minus 8. So that would be our solution on this particular problem. Now, a little side bit. There's something called remainder theorem. I'm actually getting a little bit ahead of myself in this, but this remainder theorem says if you have this x value for this problem, and you have this remainder, then those two together generate the point 8, -1 on the graph of the original equation. So that gives us one of our an extra point, which means that if we had an XY process, we would get these values as an extra point on this particular graph. Okay. Now, what that remainder theorem also tells us is that because we have a remainder and not zero, then x minus 8 is not a factor of the original equation. So if you get a remainder, your factor is that you're dividing by is not a factor of the equation. If you get a remainder of 0, then whatever factor you're dividing by, in this case x minus 8, would be a factor, and then you would have a 1 degree reduced second factor. Okay, what about this problem? New problem. In this case, we check our degrees 5, 4, and we're missing 3, 2 powers. So we have to represent them with those placeholders. Now, if they were up here, they would be plus 0x cubed plus 0x squared. Inserted right there. Now, to do the synthetic on this one, in this particular case, the factor is x minus 3. So the 0, or the root, is positive 3. Here is our remainder line. There's our addition line, and we bring down the first term. Okay, multiply, add down, multiply, add down, multiply, add down, and multiply, add down. In this case, we still have a remainder on this problem. So that tells us that x minus 3 does not go perfectly into this, so it is not a factor of that particular equation. However, it does tell us the point 33 is a point on the graph of this equation. Okay, here we're putting the powers back in. Started a 5th degree equation, ended up a 4th degree equation. We don't need to show the 0 terms. That's why we just have x to the 4th plus 12 here, and then the remainder. Okay, we have another problem. Here we start with a cubic, and we're going to try the factor x plus 10, or in other words, the 0 of -10. Okay. So we put this in. We do need to change some of our orders so they are in descending order. So we write it down, bring down the first term, multiply, add, and multiply, add. Here to get that, here to get that, here to get that, and adding down each time. In this case, as you see, we're going to have a remainder of 0. Now, the implication of that is that this factor, x plus 10, is an exact factor of that equation. Well, here's the equation once you put the variable back in. Okay. This, by the way, now that it's a square, we can factor by normal means, or we could use the quadratic formula. You know, this would generate the values x equals, in this case, positive 2/3, and in this case, it would equal positive 1. Okay, so we now have the three values, also negative 10, because this came out with a 0 remainder. We know that that is indeed a root or a 0 of this. So we have these 3 points on the x-axis, 2/3, 1, and negative 10 that are the 3 roots of that 3rd degree equation. We also know from this, when we put the x minus 10 back in here, that all 3 of these are multiplicity 1. That means that all 3 of these are going to be crossing points. So ending values for a cubic with a positive that way and this way. So what we've got in between, and also we have our y-intercept of positive 20 up here. We carry the y-axis up, so that means this thing's going to come up this way and then back down through that and down here and then back up this way. So that's going to be the general graph of this thing. So in reality, what we're saying is this synthetic division is just another way of factoring higher degree equations. Synthetic or long division is just another way of factoring higher degree equations. Now, let's look at something up here for a moment. What these scribbles are, okay? What I did up here was I simply replaced each one of these x's with a 10 to whatever power. Or, excuse me, a negative 10 to whatever power. So here I'm going to take 3 times negative 10 to the 3rd, which is negative 1,000. Then I'm going to take negative 48 times negative 10. Then I'm going to take 25 times negative 10 squared. And then I've got the plus 20 on the end. Now, these simplify, and it shows that I have a 0. So in other words, another way of determining if this is a factor, just simply a factor, based on if there is a remainder or not, is we could have said, find f of negative 10 on the equation, which in this case equals 0. Okay, both here and there. So that's an alternative way of determining if something is a factor. Likewise, what I said before, if you have a remainder, if you get something besides 0, it's not a factor, but it does give you a y value for whatever x value you're trying. Okay, and so in other words, I wrote it out over here, but here is again what I put over here. So your 3 factors are this thing factored in those 2 plus my x plus 10. Okay, and if you multiply it all out, it would come out to the original cubic equation. We're going to skip over these 2 examples for the time being, because tonight this is on synthetic division, a little bit of review rather than first exposure. Now let's go to what we call the remainder theorem. Okay, if a polynomial is divided by some factor, then the remainder is that. Now, let's go through and look at an example. We've got this. They want to use the remainder theorem to evaluate a value or a zero of -1. That's what they're attempting to do, is see if the zero, -1, is a factor or if there is a remainder. So here's our synthetic layout on this, putting in the missing degrees. Okay. We bring down the first, multiply, add down, multiply, add down, add down, add down after we multiply. And we do have a remainder of -1 in this case. That means that -1, -1 is a point on that graph. It also means that -1 is not a zero of this graph. Or in other words of saying that, another way of wording this is saying that x plus 1 is not a factor, or a -1 is not a zero. Okay. We'll look at this one. Now we've got something new. We've got a radical. This is the first time we've used a radical in one of these. We're going to see if it is a zero or if it is not. Now, if it is, we also have -√5 as a zero, but we'll have to determine that later. So we put √5 out here. It's our questionable zero. We write down the coefficients, and we do our synthetic notation. Now, I want to explain what we did here. Brought down the first. I took radical 5 times 1, gives me radical 5. These are unlike terms. So when you add them, they come out like this. Now, by distribution, I multiply this radical 5 times -4 plus radical 5. Radical 5 times -4 makes -4 radical 5. Radical 5 times radical 5 makes 5, because squaring a square root gives you the radicand. Now I'm ready to add. Combine with those, but it will combine here, and those two cancel each other out, leaving only this. So we multiply. Radical 5 times radical 5 is going to cancel each other out and give you an answer of 5. So what I'm not showing here for this multiplication then is -4 times radical 5 squared, because this one times that one, which gives you -4 times 5, which is the -20. That's how they got this value here. We subtract, or add rather, and we get 0 remainder. What that tells us that square root of 5 is a 0 of this. X minus square root of 5 is a factor of this. Now, because anytime you have a square root as a square root as a 0 of an equation, then you must also have its conjugate. Then that tells us also that you're going to end up with x equals plus or minus radical 5, and you're going to have x minus radical 5, x plus radical 5, and then some other value for x. You'll have a third value. Well, we're not going to work that on this. We're not going to find that third value on this particular problem. We're going to go on, but we're going to talk about finding that third one a little bit later. Okay. Actually, I think I will go ahead and show you that. We're going to take these values. I'm going to divide it by that negative radical 5. There's my remainder line. Okay, bring this one down, multiply, and I get negative radical 5. I add these two, those cancel, leaving me negative 4. I take negative 5 times negative 4, and I get positive 4 radical 5. These two are opposites. I get a 0. This times 0 equals 0. So that proves that these conjugates are both factors of the problem. Well, what have I got left? I started off with x cubed and x squared and x here. At this level, I had x squared and x and that. And at this level, I just have x minus 4. So if I've got x minus 4, that's my last factor. I told you I had 3 factors. I had x plus radical 5. I told you that I had x minus radical 5. And now I have x minus 4. Those are the 3 factors of this third degree equation. The 3 solutions are x equals plus or minus radical 5 and x equals positive 4. Okay, so we found all of those informations. We found all of those zeros so we could graph this equation if we needed to. Once again, this synthetic division is a manner of factoring out one term at a time till you get down to a solution. Usually after we get to a square, we're able to either factor it normally or use the quadratic formula. But because of the radicals this time, we were unable to do that. Oh, need to get rid of these. Okay, no remainder, it's a 0. And as I said, its conjugate is also a remainder. Okay, now we're going to throw in some imaginary stuff. In this case, 8i. If you have one imaginary, then you must have its conjugate also. So if this is a true 0, meaning we get a 0 remainder, then we would have to, if that is a true 0 with 0 remainder, then we would know that negative 8i is also a remainder. Is also a factor 0. I'm having a little trouble talking this morning. Okay, so we're going to divide by 8i. Remember, this means x minus 8i is the proposed factor. All right, so let's go through this. This one's going to be somewhat similar to the radical one that we did a moment ago. Bring down the first term, I multiply, I get 16i. These are unlike terms, so when I add them, I get this. So now what I have to do is by distribution, I have to multiply this, okay? Which that gives me the 8i, and this gives me this 128 right here. The way I get that is I have 8i times 1 plus 16i. I distribute it, I get 8i here. We've already done that. I distribute this, and I happen to get plus 128i squared. That I squared, I have to replace with a -1. So therefore, I end up with the 8i plus, minus 128, because -1 times the positive 128 there gives me that. So that's how I came up with this minus -128. Okay, continuing, I subtract down here, the 128s cancel out, leaving me the 8i. So 8i times 8i is 64i squared. Okay, 8i times 8i equals 64i squared. The I squared once again equals -1. So these two together then equal -64. That's how I got that value. I add them, and wonderful, I get a 0 remainder. Since there is no remainder, then that tells you that 8i is a 0. Now, what does that also tell you? Then it tells you that -8i is also a 0. Okay? It also tells you that this is no longer a proposed factor, but it actually is a factor. But I would also have to have x plus 8i as a factor in this particular problem. And then I would have the third degree to go. Now, how would we find that third x value? Well, we would divide this by 8i and continue like we did before. Okay? And our answer down here would give us our final x value. I'm not going to do this. It's very similar to what we did on the radical problem just a few moments ago. Okay, here's a comparison of long division and synthetic division. If you're given that x minus 3 equals 0, then you would have the solution or 0 of x equals 3. Over here, we divide by the factor. Over here, we divide by the 0 or the root. Okay, here we have the x's in, here we only have the coefficients. We go through our long division just like we did before. In this case, getting a root of 0. That tells us that x minus 3 is indeed a factor of this. Okay? Over here in the synthetic, we divide it, and we put the x's back into this. We're dropping from starting with a cube, So these become a square, gives us this equation. So what this now means is we've got, in this particular case, that means that we've got this x minus 3 times that equals 0 for our polynomial factoring. This thing we can probably factor, okay? We can probably factor that one. I'm not going to do it right now, but we would get the 3 solutions for a third degree equation that way. We also could use the quadratic formula on this if we needed to. Well, here are just our practice ones. We're going to pass through those right now. The factor theorem. Okay, I've already talked to you about this. This is just discussing the difference of if you have a root or a 0 and you get a 0 remainder, then that produces the factor. Or if you have the factor, you can find the root that has a 0. Now let's look at this one. We're going to do this division. We're going to divide by x minus 1. If we were doing synthetic, we would be dividing by -1. Here, we've done this. I get a 0 remainder. Then what that means is, in this particular case, we now have x plus 1 times 2x squared plus 3x plus 4. We have now broken this into those 2 factors. Okay? Now, not tonight, or not today, rather. We're going to have a lesson on what numbers to try if we want to break this down. Well, because this is second degree, we can use normal factoring methods, or we can use quadratic formula to find the other 2 zeros. If this were any degree higher than 3, then we would have to use those methods, the rational products rule. Well, in any case, we got a 0 remainder, so that is a factor. That also means that x equals -1 is a root or 0. Okay. Okay, here's another one. In this problem, it tells us we need to see if x plus 4 is a factor. If x plus 4 is a factor that we're trying, if x plus 4 is a factor that we're trying, then x equals -4 would be the root that we would use for synthetic division. So here are the coefficients, and we do the work. Okay, we bring down, multiply, add. Multiply these 2 to get that, add. Multiply these 2 to get that, and we do have a 0 remainder in this case. This becomes 6x squared minus 13x minus 8. Okay? That also means that, yeah, x plus 4 is a factor. Verifies that -4 is a 0 or a root of this particular equation. This, in turn, could be put into the quadratic formula with a second degree here, and you can find the other 2 solutions for this equation. Okay, this is just, and there's the point on the graph that would generate also. And this repeats what I've previously said. Okay, in this case, we're doing a test to see if x minus 6 is a factor. Okay, if we have x minus 6, then positive 6 would be the proposed 0. Put it in here, bring down, multiply, bring down, multiply, bring down, multiply, bring down, multiply, bring down, and multiply, and bring down. In this case, we got a 0 again for our remainder. So therefore, 6 is a solution of this problem, and x minus 6 is a factor of this problem. We have reduced this to the factor x minus 6 times to the 4th degree equation here. Now, at this point, we could determine another root to try, which comes in a future lesson, and then do a synthetic division on this to reduce it to a 3rd degree equation, and then to a 2nd degree equation where we could use the quadratic formula. Because in this particular case, we would have potentially 5 x values. By the way, this does factor into that, into those two terms. This term, in turn, factors into those two. Into those two, leaving us this. Now, that one we can solve using the property of square roots. Okay? So if you got 4x squared plus 1 equals 0, then you have 4x squared equals -1 when you take this over. Now, the next step, take the square root of both sides, plus or minus. Okay? Well, we do that, and we're going to get 2x here, and over here we're going to get plus or minus I. Okay, because of this negative square root. Now, what does this mean for the, well, we've got to finish. We need to divide both sides by 2. So x becomes plus or minus 1/2, negative plus or minus 1/2 I. Okay, what would this look like as a factor? Well, it would look like x plus 1/2 I and x, let me write them down here, x plus 1/2 I and x minus 1/2 I. So now we have 1, 2, 3, 4, 5 factors for a 5th degree equation. Okay, these two are imaginary values. Remember, they always come in conjugate pairs. These two would give me a plus or minus 1, and this one, of course, would give me a positive 6 for us to graph the equation. Okay, write a polynomial of degree 3 Just one moment. Okay, we're going to our next step. We're going to be giving you the degree of the polynomial. We're going to give you some of the zeros, some or all of the zeros, and then the requirement is for you to multiply out and find the full polynomial. In this case, we have zeros of 2 with a multiplicity of 2. We have a third zero of -5. Or in other words, we have -2 to the second degree times x plus 5, or x minus 2 squared times x plus 5 is what this information tells us. Now we have to multiply these out to find the polynomial. Well, this one multiplies pretty easily using your form A on or form B on my handout sheet. So we get x squared minus 4x plus 4. We bring this one down. Now we're going to distribute this x plus 5 times this trinomial. Okay, the x here squared, and here, and here, then with the 5, and here, and here. We're going to combine like terms. That produces this equation. This is the polynomial resulting when you have zeros of 2 multiplicity 2 and -5 multiplicity 1. Okay. Our next lesson that we're going to have starting next week is going to deal with the rational zero theorem. Now, what have we done tonight? We've done some review of synthetic division. We also did synthetic division with radicals. We did synthetic division with imaginary values as well. So we expanded that skill. We determined the remainder theorem. If the remainder after division is 0, then we have a factor. If the remainder is other than 0, then we just have a point. Okay, then we did the factor theorem, which says that if you have a remainder of 0, then your factor is a factor of the equation. What is this business about division? It's a process of factoring down till you get to degree 2, where you can use the quadratic formula or normal factoring methods to find all of the solutions of an equation. With that, we'll call a halt to this particular lesson.